In 1929, Benito Mussolini gave an order that made no economic sense on paper: drain an entire volcanic lake. Not for water, not for farmland, for a ship. Engineers spent the next several years pumping millions of gallons out of Lake Nemi, 17 miles outside Rome, chasing a story that a Roman emperor had scuttled two enormous pleasure barges into its floor almost 1900 years earlier. When the water finally dropped low enough, they found something that should not have existed. A wooden hull well over 200 feet long, sheathed from the waterline down in sheets of lead. Bronze valves. Rotating ball-bearing mechanisms for revolving statues on the deck. A drainage system so close to modern hardware that the engineers who cataloged it in 1929 recognized it on sight. This was built under the reign of the Emperor Caligula, around the year 40, nearly 2,000 years before anyone would call a ball bearing an invention. And that ship was not even the largest wooden vessel the ancient world put in the water. Somewhere in the harbor of Alexandria, more than 2 centuries before that, a ship was launched that measured, by the most conservative ancient accounts, close to 420 feet from bow to stern. Longer than a football field, including both end zones. Built with no iron forge large enough to cast an engine, no block and tackle rated for more than a few dozen straining men, and no tool sharper than a bronze axe or an iron adze. So here is the question almost nobody answers properly. If the ancient world had no steam, no hydraulics, no machine capable of lifting more than a rope, and a crew of men could manage, how did they build wooden ships larger than a modern stadium? Ships engineered so precisely that some of their solutions were not matched again for close to 2,000 years. I have spent weeks going through the surviving accounts, the writings of Athenaeus, who preserved a lost eyewitness description by a court official named Calixenus of Rhodes, the excavation reports from the Nemi ships before they were destroyed by fire in 1944, and the hull studies from smaller, better-preserved ancient wrecks like the one found off Kyrenia, Cyprus, which let modern archaeologists finally reverse engineer exactly how these hulls went together, plank by plank, joint by joint. And the thing that stays with me, more than any single number, is this. We know the name of the shipwright who built the Great Republic in Bath, Maine, in 1853. We know the name of the man who died steaming a plank onto her sister ship 6 years later, what he earned, where he was buried, and what his son did with his life. We do not know a single name of the men who built the 400-foot ship at Alexandria. Not the master shipwright. Not one rower, one caulker, one carpenter. Thousands of men gave years of their lives to something larger than any building of their era, and history did not think their names were worth the ink. Here is what you need to understand before any of it makes sense. Ancient Mediterranean shipbuilders did not build the way the American and European yards of the Age of Sail did. A 19th century shipwright built a skeleton first, a keel, then ribs, then planks nailed onto that skeleton, the way you'd frame a house before you sided it. The ancient world did the opposite. They built the skin first, and the skeleton came later, almost as an afterthought, stiffening a hull that was already, on its own, strong enough to float and hold its shape. That single reversal, shell before skeleton, is the key to almost everything that follows. It is also almost completely forgotten outside of a small circle of maritime archaeologists, because for over 1,000 years, nobody built ships that way again, and the method itself very nearly vanished from human memory. Before we get to the 400-foot ship, you need to see what came out of Lake Nemi, because it proves something the skeptics of ancient engineering never expect. For centuries, local fishermen and the occasional diver had reported timber and metal fragments snagged in their nets, and rumors persisted that the Emperor Caligula had built ships on the lake unlike anything else in the Roman world. Most historians treated it as folklore. Emperors built palaces. They did not build 230-foot barges on a small volcanic lake with no access to the sea. The draining operation, ordered under the fascist government in 1928 and completed in stages through 1932, uncovered 2 vessels. The larger measured roughly 240 feet long and 66 feet at the beam, proportions closer to a small cruise ship than anything associated with a barge. The hulls were built shell first from oak and pine, edge-joined with thousands of mortise-and-tenon joints, a technique where a rectangular tongue cut into the edge of one plank slots into a matching pocket cut into the edge of the next, then is pinned through with a wooden peg so the 2 planks lock together almost as one continuous piece of wood. There was no keel-first frame for the hull to hang on. The shell of pegged planking was, structurally, the ship. Frames were fitted afterward, more to brace the hull for its heavy internal cargo, marble floors, plumbing, bronze fittings, than to hold the hull together at all. What stunned the 1929 excavation team most was the hardware. Bronze valves for controlling running water on deck, matching the accounts of onboard baths and heated floors. Rotating pivot mechanisms, fitted with what are functionally roller bearings, used to turn heavy statues or platforms with minimal effort. The same working principle used in machinery today. Lead sheeting, nailed over a layer of tarred fabric, protecting the underwater hull from rot and boring shipworm, a technique ancient shipbuilders used for centuries, before it was rediscovered by naval architects. Some sources say, more than 1,500 years later. The ships were housed in a purpose-built museum on the shore of the lake. In 1944, in the last chaotic weeks of the war in Italy, both vessels were destroyed by fire. Accounts differ on whether it was retreating German soldiers or Allied artillery. Almost everything we now know about the Nemi ships survives only in the photographs, drawings, and measurements the 1929 excavation team took before the fire, because the ships themselves are gone. So is nearly every name of the men who cut, pegged, and lead-sheathed that hull in the first place. We know the emperor who commissioned them. We do not know a single shipwright's name. But the Nemi ships prove the underlying claim that everything else in this video rests on. A civilization with no engine, no hydraulic press, and no powered saw was capable of hull engineering, pegged plank shells, lead cladding, precision bearings, that would not look out of place on a drawing board 1,000 years later. And if a lake barge for an emperor's private amusement carried that level of sophistication, it forces a harder question. What did the largest actual warship in the ancient Mediterranean look like? Around 220 BC, in the shipyards of Alexandria, under the reign of Ptolemy IV, a ship was launched that ancient writers called simply the 40. Tessera Konteras in Greek, a reference to the 40 files of oarsmen worked into her design. The most detailed surviving description comes from a court official named Calixenus of Rhodes, whose eyewitness account survives only because a later writer, Athenaeus, quoted long passages of it in a book about food and dinner parties 3 centuries after the ship existed. That alone should tell you something about how close this entire chapter of history came to being lost. The most important engineering document of the ancient shipbuilding world survives as a footnote inside a book about banquets. Today, according to that account, the ship measured close to 420 feet long, roughly 57 feet across the beam, and stood so tall that the highest point of the stern rose nearly 80 feet above the waterline, the height of an 8-story building, floating. She carried an estimated 4,000 rowers, 400 additional sailors and deck crew, and space for close to 3,000 Marines, putting her total complement at over 7,000 people. For comparison, the Great Republic, the largest wooden ship built in 19th century America, 94 men over 11 months, would have fit inside her hull several times over and could have been crewed entirely by a single one of her 40 oar banks. Modern naval historians have argued about this ship for over a century, and here is where the story gets genuinely interesting, because it touches on exactly the kind of erased history this channel exists to dig up. A conventional single-hull 400 feet long, powered by human-rowed oars stacked 40 files deep, runs into real physics problems. The leverage and hull stress required would push far past what timber and rope rigging could reasonably survive, even accounting for ancient engineering skill. For decades, some historians dismissed the entire account as court flattery, exaggerated propaganda designed to make Ptolemy look powerful, and nothing more. But newer analysis, cross-referencing the same account against surviving evidence for how Mediterranean shipbuilders actually solved impossible-scale problems, has proposed something else entirely. That the 40 wasn't a single hull at all, but a catamaran, twin hulls, each roughly 200 feet long, built shell-first in the same pegged plank technique as the Nemi barges, joined by a massive connecting deck strong enough to carry marines, catapults, and boarding towers. Built that way, the physics work. The oars on both hulls could be coordinated by drummers keeping stroke rhythm across the width of the deck, a technique ancient sources confirm was used on smaller multi-bank warships. If that reconstruction is right, the 40 wasn't just the largest wooden ship the ancient world built, It may have been one of the first true catamarans in naval history, a design principle modern racing yachts and military vessels still use today, quietly rediscovered by engineers who had no idea Alexandria got there first. Either way, whether single hull or twin, building her required a shipyard workforce measured in the thousands, working simultaneously, something the Ptolemaic dynasty, ruling the richest kingdom in the Mediterranean and commanding Egypt's grain wealth, could actually afford to mobilize. And that mobilization is the part almost nobody talks about, because it means understanding exactly how ancient hands, with no machinery beyond rope and leverage, physically put a ship that size together. Here is where we get into the part of this story that modern shipbuilders find almost unbelievable, because it inverts everything they'd assume about how you'd have to build something this large. A 19th century shipwright, like the men on the Kennebec River, built the skeleton first, a keel, then ribs rising from it, and only then a skin of planks nailed onto that frame. Ancient Mediterranean shipwrights built the opposite way. The hull's outer planking went on first, plank by plank, edge to edge, with almost no internal framework to guide it. The shipwright worked by eye and by a mental template passed down through apprenticeship, curving each plank's shape by hand, without a single drawn blueprint the way we'd understand one today. The planks were joined edge to edge using a technique called mortise-and-tenon joinery, and this is the piece of ancient engineering that genuinely startles people who see it up close. Along the edge of each plank, a shipwright cut a series of rectangular slots, called mortises, spaced only a few inches apart. Into each slot he fitted a separate rectangular tongue of hardwood, called a tenon, that locked into a matching slot cut into the edge of the neighboring plank. Once the two planks were drawn together, the tenon sat locked inside both mortises like a spline, and the shipwright drove a wooden peg straight through a drilled hole in the plank and through the tenon itself, pinning the whole joint permanently in place. A single medium-sized ancient hull could require somewhere in the range of 20,000 of these hand-cut joints, each one shaped with a hand chisel and mallet, each one fitted tightly enough that the completed seam needed almost no caulking at all, a level of precision closer to fine furniture making than what most people picture when they think ancient shipyard. On a vessel the scale of the 40, or even the smaller Nemi barges, that number climbs into the tens of thousands, cut by teams of shipwrights working plank after plank, week after week, entirely by hand, with no two joints identical, because no two curves of the hull were identical. There was no template that could be mass-produced. Every joint was its own decision, made by a craftsman reading the curve of the wood in front of him. Only once the shell of pegged planking had taken shape, essentially a hollow, self-supporting hull, strong enough on its own to hold water out, did the builders go back inside and fit internal frames, notching them to match the exact contour of the planking they were bracing, rather than the other way around. It is, structurally, closer to building an eggshell first and adding internal struts afterward than it is to framing a house. Timber selection followed similar logic to what shipbuilders would later rediscover in Maine. Shipwrights sought out naturally curved oak limbs and branch junctions for frames, rather than trying to force straight timber into a bend it would eventually split trying to hold. Moving timber of this scale required nothing more sophisticated than rope, wooden rollers, sheer leg cranes made of two-lashed poles, rigged with block and tackle, and enormous numbers of coordinated men. Alexandria's harbor had covered ship sheds, long stone and timber buildings built directly at the waterline, specifically so a completed hull could be launched by sliding it downhill into the water on greased rollers. The same basic principle the Kennebec yards would use over 2,000 years later for the Great Republic. The physics of moving an enormous object with limited force were solved the same way twice, 2 millennia apart, by two civilizations that had no contact with each other's methods at all. And underneath every one of those 20,000 joints, every timber dragged into place, every hull rolled down into the harbor, were the actual hands that did it. That's the part of this story history chose not to keep. If you watched a video on this channel about the Great Republic, or the Bath shipyards, you'd have heard about a man named James Cormier, a planker killed on a 19th century ship 240 feet long, a man whose wage, wife, burial plot, and son's entire career we can still trace through surviving payroll ledgers and probate filings. That level of detail exists because 19th century Maine kept paper, coroners filed reports, Shipyards kept daybooks, widows applied for final wages, and the receipts survived in an archive. Ptolemaic Egypt kept records too, some of the most extensive administrative paperwork to survive from antiquity, written on papyrus, covering taxes, grain shipments, land leases, and temple accounts in extraordinary bureaucratic detail. And yet almost none of it, as far as we can trace, ever bothered to record the individual men who built the largest ships in the ancient world. We know the name of the king who commissioned the 40. We know the name of the court official who described her for a dinner party audience 300 years later. We do not know the name of a single shipwright who cut a mortise, a single hewer who selected a curved timber, a single laborer who hauled a plank into a ship shed and never got to see the finished hull sail. Some of that labor was almost certainly enslaved or conscripted, as much ancient large-scale construction was. Ptolemaic Egypt ran on a combination of paid skilled craftsmen and compulsory labor drawn from the wider population, and shipbuilding at the scale the 40 required would have needed both. Skilled shipwrights, likely paid and respected within their trade, working alongside far larger numbers of unskilled or forced labor moving timber, hauling rope, and doing the punishing physical work that never required a name in a ledger because nobody with the authority to keep ledgers considered it worth keeping. Injuries and deaths on a project pulling together thousands of men, heavy uncured timber, rope under enormous tension, and no safety equipment of any kind would not have been rare. They simply were not the kind of thing anyone thought was worth writing down. That absence is not a small detail. It is, in its own way, the actual ending of this story. The wooden ships themselves are almost entirely gone, burned, sunk, broken up for timber, or reduced to what a small team of engineers could photograph in the few years before fire took the last physical evidence at Lake Nemi. But the men who built them are gone more completely still, because they were never recorded to begin with. Somewhere in the 2nd century BC, the skill of shell-first mortise-and-tenon shipbuilding that put a 400-foot ship into the water at Alexandria began to fade. As Rome's power grew and its shipbuilding needs shifted toward faster, cheaper construction for a navy that needed hundreds of vessels rather than one enormous flagship, the labor-intensive precision of tens of thousands of hand-cut joints per hull gave way to quicker methods using more internal framing and fewer, looser plank joints. The old technique did not disappear all at once. It simply stopped being taught, generation by generation, until the shipwrights who still knew it had died, and nobody had written down enough of what they knew for anyone to recover it. Not until 20th century archaeologists, working from wrecks like the one at Kyrenia, pieced the method back together timber fragment by timber fragment, almost 2,000 years after the last man who learned it as a living trade was gone. So when you ask how ancient workers built ships larger than football fields without powerful machinery, the honest answer is, with an amount of skill, coordination, and sheer accumulated craft knowledge that took the modern world until the 20th century to even fully understand what it was looking at. And they did it while leaving behind almost none of themselves. No names, no wages, no graves we can point to, nothing but the ghost shape of a joint cut into a 2,000-year-old plank. Precise enough that when archaeologists finally found one intact, they knew immediately a master had made it, even though they would never know his name. The lake at Nemi is calm again now. The harbor at Alexandria has been rebuilt many times over, most of the ancient city's shoreline lost to earthquakes and rising water centuries ago. The 40 never survived long enough for anyone to measure her directly. She exists only in one dinner party author's borrowed description of a description. But for a little more than 2 centuries, from the height of Ptolemaic Egypt through the height of the Roman Empire, human beings built wooden structures larger and more sophisticated than almost anything else on Earth, using rope, timber, bronze tools, and thousands of anonymous hands, and then let almost every trace of who did the actual building disappear. If you found this as astonishing as I did putting it together, hit subscribe. It's the only way stories like this keep finding their way into your feed. And if you want to see what happened when a much later crew of shipwrights tried to build something almost as large with only slightly better tools, go watch the video on the Great Republic next.